Dear fellows, welcome to IT-KnowledgeBase. In this steering lecture, we will address essential security settings in Secure Shell, also known as SSH, which is a cryptographic network communication protocol that permits secure communication and data exchange between two devices over an unsecured network. Today, everything is managing remotely is significantly imperative, whether you are hosting your Linux servers or a seasoned systems administrator who has the responsibility to manage Linux boxes remotely. And the most important is to secure your SSH service from very likely internal and external attacks. In this video, I will address many dynamic configurations in which you are definitely learn how to professionally secure your SSH protocol in a real scenario where you are remotely managing your critical servers and are curious to know how to secure all of them. We will see in action how to install, enable, configure, and secure your OpenSSH protocol and install it as a persistent service. Introduction to OpenSSH. Let me emphasize some importance of OpenSSH nowadays. SSH now becomes a sophisticated and must-have implementation service that we use every single day to log into our remote Linux servers and take care of our admin duties. Without SSH, managing Linux servers would be more complicated and less secure. That does not mean SSH is configured right off the box to your liking. There are a few weaknesses in the default configuration and the way you are probably using the tool. Users use SSH to log into applications or remotely execute command line on terminals. For devices to build a connection, both need to have SSH installed and working on their systems. If you are looking for a way to install, enable, and most important is to secure your OpenSSH in Linux systems, the most renowned is Ubuntu and CentOS distributions. Then follow this step-by-step video lecture. We normally see CentOS and Ubuntu operating systems uses more often on the cloud systems. Whether you are using managing and unmanaging VPS hostings, dedicated servers, or shared and reseller hosting accounts, all the providers all out use CentOS distributions frequently for hosting websites and provide cPanel WHM, FTP, WHMCS, and EXIM emails privileges to their customers and clients to manage their cPanel WHM subscription through a web panel or across the SSH terminal protocol. In my virtualized lab, I am using Ubuntu 22.10, which is the latest version at the time of this recording. In my virtualized environment, a pfSense firewall is in place, or place any firewall as you like, and open SSH port number 22. Ubuntu and Windows act as SSH client. I am super confident in using this securing approach in all my hosting servers, dedicated servers, and VPS servers. This is a complete step-by-step demonstration that will help you to install, enable, and most imperative is to secure SSH service from every possible internal and external threats, and especially from the cyber attacks. This is not only appropriate for Ubuntu operating systems, but also applicable for CentOS, Red Hat, and all other Linux distributions as well. Okay, so let's start now. Content cover in this lecture. We will see installing, enabling, and connecting OpenSSH server, UFW, also known as uncomplicated firewall, essential top 19 tips for securing SSH, and at the end we will wrap up the video by summarization. Before we dive into how to install, configure, and securely connect, and do the essential hardening of SSH-enabled Linux boxes, we should comply with cybersecurity best practices. We will first update and upgrade our Linux operating system, then install OpenSSH server service, and make sure services auto starts after every reboot. Verify the status of the SSH service should be in an active state, then connect to your SSH server from Linux and Windows boxes, and disable the SSH service completely only if it is required in any case. After satisfying all these, we will move on to deep dive into securing our SSH server. Let's perform the essential recommendations first. Before you begin the installation of OpenSSH, firstly open up the Ubuntu terminal and confirm that your system is up to date. Now let's move on to install OpenSSH. OpenSSH is not present on the system by default. Therefore, run this command to initiate the OpenSSH installation procedure on Ubuntu server. The below given output indicates that we have successfully installed OpenSSH on our Ubuntu system. After successful installation, you need to enable it and auto start after you reboot your Linux box by utilizing the following command. Next, validate that the OpenSSH is working properly and there are no issues with the help of the following systemctl command. As you can see from the output, OpenSSH is currently active and running on our Ubuntu system. Connect to SSH server. Once you have installed OpenSSH and it is in a working state, you can now connect your system from another remote system. However, you have to make sure that OpenSSH is installed and enabled on that remote system as well. Before you connect to a server, you need to have an internal or external IP address or a host name and the login details, likewise username and password of the account you want to connect to. Then run the below given command. From a Linux system, you can issue a SSH command to connect to your server. If you are connecting very first time, you should ask to accept the certificate fingerprint and confirm your authentication by entering your password. And now you are connected. From your Windows client, you can use PuTTY or PowerShell to connect to your SSH server. Type SSH, username, and your SSH server IP address or hostname. As from Windows, I am connecting to my SSH server very first time, so that we might ask to accept the SSH fingerprint. Type yes and confirm your password. Now we are successfully connected to our SSH server. Disabling OpenSSH. When you do not want to use OpenSSH, then you should disable it for security purposes to avoid being detected by any malicious bots. To do so, execute the following command in your Linux box. Now verify your SSH service. Now it's completely disabled. We have compiled the easiest method to install and enable OpenSSH on our Ubuntu box. Let's do some basic firewalling stuff. UFW firewall, also known as uncomplicated firewall, is a firewall in the Ubuntu box and its state is disabled by default. I would endorse you all to enable and configure UFW firewall in all of your critical servers to simply allow and deny the absolute traffic. UFW is installed by default on Ubuntu. If it has been uninstalled for some reasons, you can install it though. UFW firewall is a simplified firewall management interface that hides the complexity of lower level packet filtering technologies such as IP tables and NF tables. If you are unsure, but it's safe to check the firewall state first, SSH traffic should pass by the UFW firewall. If you are looking to get started securing your network and you are not sure which tool to use, UFW may be the right choice for you. Here I would like to show you how to set up a firewall with UFW on Ubuntu to generously pass the SSH traffic. A quick introduction to UFW firewall. UFW is an acronym for an uncomplicated firewall. Recommended to use for securing a server with an uncomplicated firewall is super easy and highly recommended. You must be logged in or use root privileges. Difficulty is very easy. UFW is installed by default on Ubuntu. If it has been uninstalled or not installed for some reasons, you can install it though. Using IP version 6 support, UFW also supports IP version 6 traffic to enable. IP version 6 will work as well as long as you enable it. If your Ubuntu server has IP version 6 enabled, ensure that UFW is configured to support IP version 6 to manage firewall rules for IP version 6 and IP version 4. To do this, open the UFW configuration file with Nano or any of your favorite editors. Then make sure the value of IP version 6 is set to yes. It should look like this. Save and close the file. Now when UFW is enabled, it will be configured to write both IP version 4 and IP version 6 firewall rules. Or if you enable IP version 6 after the UFW was enabled, then simply restart the UFW service. Install and configure UFW firewall and allow SSH traffic. Let's see in action how to install and configure the UFW firewall and allow SSH traffic. However, it is installed by default in the Ubuntu server and desktop editions, or if it is not there or uninstalled for some reasons, then ensuring this section to install. Please note here, if we enabled our UFW firewall now, it would deny all incoming connections. This means that we will need to create rules that explicitly allow legitimate incoming connections for SSH or HTTP, for example, if you want our server to respond to those types of requests. If you are using a cloud server, you will probably want to allow incoming SSH connections so you can connect to and manage your server. Make sure the UFW firewall is installed. If not, just issue this command. UFW is already the newest version and it's installed by default. Check the UFW firewall status. It's inactive. Now enable the UFW firewall. Check the status again. Now it's active. And now allow incoming SSH traffic. Just pass the SSH traffic through UFW. UFW allow SSH, or you can type UFW allow port number 22. You can type any of your convenience. I will use UFW allow SSH. Now rule for IP version 4 and IP version 6 has been added. To save the changes of UFW, we will enable and reload the UFW. UFW enable and UFW reload. Firewall is active and enable on system startup. Securing SSH secure shell. How to secure SSH, recommendations and best practices. I am going to share comprehensive security tips composed of my personal experience and real scenario based best practices to secure SSH services from every possible internal and external threats and different types of brute force attacks. You can feel free to follow these tips in almost all Linux distributions. Now back to our SSH server and open the SSH configuration file. Before we dive into the hardening of our SSH server, you all should know where the SSH configuration file exists in. SSH configuration files are a powerful tool for automating SSH connections. The default location of a user-specific config file is in the user's home folder. Go to .ssh folder and open the config file. Whereas the system-wide configuration file for all users is in etc/ssh/ssh_config file. Open the configuration file. Security tip number 1. Changing the SSH protocol and default port number. One of the most important thing to do is to use the secure version of SSH protocol version 2. SSH version 2 is an improved version of SSH 1. SSH version 2 has a number of new features like encryption, ciphers and support for public key certificates to provide more security. SSH protocol version 1 is no longer supported and should not be used and is only offered to support legacy devices. So we don't have to change anything in the SSH configuration file here. SSH version 1 is outdated now and all the Linux boxes use version 2 by default. So for the sake of substantiation, we can gratify our assessment of whether our connection is using secure and encrypted with SSH version 2 or unsecured with SSH version 1. Jump back to our SSH client machine and type sudo SSH username and your server IP address or host name. We can simply add a switch tag 1 while connecting to our SSH server, which means forcing the connection to use version 1. Hit enter your password. The below message clearly shows that the SSH protocol version 1 is no longer supported. If you repeat the command and replace the tag 1 with tag 2, enter your password, and now you are connected. Now switch back to our server where our configuration file is still open. Next, the first thing we'll do is to change the default port number 22 of SSH, which is widely used in brute force and other types of SSH attacks. To do this, open the SSH daemon configuration file with nano or any of your favorite editor. In that file, look for port number 22 and customize this default port to something restrictive. I like port 1979. Press Ctrl O, save the file and close the file with Ctrl X. Restart the SSH daemon. Don't forget to allow this custom SSH port from the UFW firewall. Rule is already added, so it's not going to overwrite again. Do netstat to verify your new SSH port is ready to listen. Now jump back to our client machine and make sure you can reconnect to the server with adding the tag P switch with your customized port. Enter your password and now you are connected. Security tip number 2. Disable X11 and TCP port forwarding. The X11 forwarding option is enabled in many Linux distributions by default. It is a mechanism that permits remote users to execute graphical applications from their SSH session. It can be misused if things go into the wrong hands, as SSH client can easily generate fake cookies and transmit over the remote SSH server after they establish the connection. To prevent such kind of security gaps, it is better to disable X11 forwarding. Disable X11 and TCP port forward because attackers can use these weaknesses to gain access to other systems on your network. To do this, reopen the daemon configuration file and look for the following two lines. X11 forwarding set to no. Allow TCP forwarding set to no. Save and close the file. We are not restarting the SSH daemon now. We'll hold off on restarting the SSH daemon until we've taken care of the other configuration. Security tip number 3. Disable or reject request with no or blank password. Within the SSH daemon file, we want to prevent user with blank password from gaining access. You should not have to bother with this if you've set up a policy that disallows empty passwords. But it's always better to be safe than sorry. In the daemon configuration file, look for the line permit empty password. Change the line to uncomment and it's set to no. Save and close the file. Since we are done with the daemon configuration, restart the SSH daemon with systemctl. Security tip number 4. Restrict SSH logins to specific IPs. This is a very critical and must-have configuration that everyone should take it seriously and configure in your SSH server. By default, there is no restrictions to accessing the SSH server from anywhere with any IP address. As part of the security concern, it is a good practice and recommended to permit only a specific IP address. For example, if you have a corporate and business network with a static public IP address, then permit only those and deny the rest of the IP addresses. First, check the allow and deny host files with the help of the grep command. There are two files, host.allow and host.deny file, which are self-explanatory. If you want to manage whitelist, just use host.allow file and use host.deny file for restrict all rest. We can also use single host.allow file to manage all allow and deny sites like this. The above configuration will permit only two IPs, 11.117 and 11.118, and deny all other IP addresses access to our SSH server. However, you can also manage allow and deny sets separately. To do so, restrict all the users in host.deny file and manage allow list in host.allow file like this. Open host.deny file. At the bottom of that file, add the following line. Save and close the file, and it should not connect and deny access to it. Open host.allow file and don't forget to remove sshd deny line. Save and close the file. If you want to allow all machines on your LAN, you could use mention a whole network insider style. Save and close the file. Please note, restarting the service in this section is simply not required. Security tip number 5. Use SSH key authentication. This is one of the most important piece of instruction. You may have not to be given a password, but rather give an SSH key or even ask to generate one. In the physical world, a key unlocks a door. Similarly, an SSH key is used to unlock access to your account on a server. If you do not have a key, you cannot unlock the door. Using SSH key-based authentication is the highest security setting than using standard password-based authentication. Before enabling the SSH key-based authentication and disabling password-based authentication, you should have to understand their basics and then configure it properly. Number 1, user account should exist on the server. Number 2, on the client side, user should generate the SSH key from the authorized user account only. Number 3, copy the SSH ID to the server, and password authentication is required for this step. And the final step is disable the password-based authentication. You can also watch my video 3 steps to implement SSH key-based authentication, where I have precisely covered all the steps. The link is also provided in the description. Now switch back to our client machine, log into user 1. and perform the key generation and copy ID procedure. It may also ask you to accept the SSH key fingerprint and a password or passphrase for additional security along with the key-based authentication. Just accept the default. But in this demonstration, we will simply ignore the password to enter. Hit enter, enter again, and that's it. Having an SSH key without a passphrase can allow you to automate and schedule tasks that require logging into the remote system. Now copy your SSH ID to your server and enter your user with a password created on the server. Here you have to be noticed we are not using the default port number 22 instead of using a custom port. So we have to specify a port number with the tag P switch. Hit enter and confirm your password. After copying your SSH authentication key to the server, now open a new terminal and make sure you can still connect to the server via SSH. You are now connected with the SSH key-based authentication. Switch to the server and then disable password authentication by opening the SSH daemon configuration file one more time. Look for the line password authentication. And set it to no. Save and close the file and restart the SSH daemon. Now only those users who have their SSH keys on the server will be able to log in with the SSH keys based authentication. Security tip number 6. Disallow root login. In all the Linux Unix operating systems, the root user is restricted by default to logging in by SSH. However, it is safe to check and learn how to enable and disable root logging in through SSH. Prohibit the root user to log in via SSH. Similar to before, open the SSH configuration file and change the permit root login to no. Or if you wanted to allow root to log in and authenticate through SSH, then simply add yes here. But in this demonstration, we are not willing to allow root user here, so we just set it to no. Save the file, exit it out, restart the SSH daemon with systemctl. And now the root user will not be able to log into the server via SSH. Security tip number 7. Set an idle timeout value. It's much safer to establish a timeout limit. The SSH connection will be dropped if the inactive period matches the time limit. Similar to before, open the SSH config file and scroll through the file until you see the line that starts with client alive interval. Remove the hash from the start of the line and change the digit 0 to your desired value. We've used 300 seconds, which is 5 minutes. Save the file, restart the SSH daemon, security tip number 8. Set a limit for password attempts. Defining a limit on the number of authentication attempts can help thwart password guessing and brute force attack. This is also a great aid to prevent the account from a brute force attack. After the designated number of authentication requests, the user will be disconnected from the SSH server and receive a too many authentication failure message. By default, there is no limit, but that is quickly remedied. Like before, open the SSH configuration file again. Scroll through the file until you see the line that starts with maximum authentication twice. Remove the hash from the start of the line and change the digit 0 to your desired value. We've used 3 here. Save the file when you made your changes and restart the SSH daemon. Security tip number 9. Create a custom SSH banner. You can create a banner to convey a specific message or a security warning message to your users. To do this, create a text file and put your message into it. Create a new file name, let's say banner.txt, or any name you like in your desired location. I have created in the etc/ssh folder and pasted our specific message to all SSH users. Now edit SSH config file. Scroll through the file until you see the line that starts with banner and type the exact banner.txt location. Save the file when you made your changes and restart the daemon. Switch back to our client machine, attempt the SSH connection again, and make sure your message is conveyed through the SSH connection. As you can see, your banner.txt file is working. Security tip number 10. Allow only specific users via SSH. By default, all users can log in using SSH, but if you want to allow only specific users to log in via SSH, then you can use allow users and deny users setting to configure that. Edit SSH configuration file. Scroll all the way down, and at the bottom of this file, simply type the allow and deny users entries. In our case, I impatiently wanted to allow some of our workaholic users and deny some wicked users. Save the file when you made your changes and restart the SSH daemon. Switch back to our client machine and test user 1 first. You are permission denied. Now switch to another terminal. Try the same connection with the user 2. And now you are authenticated. Security tip number 11. Disable users.rhost file. Since we are using SSH, so we will disable .rhost authentication, which will prevent users from using obsolete RSH commands such as RCP and RSH on the local system without a password. On Unix-like operating system, the RSH command executes commands on a remote shell. Edit the SSH configuration file. At the bottom of the file, you have to add ignore rhost yes. Save the file when you made your changes and restart the SSH daemon. Security tip number 12. Disable host-based authentication is a security risk and is disabled by default. If it's not disabled by default, then you can disable it. Edit SSH configuration. Scroll down and navigate host-based authentication. Uncomment the line and set it to no. Save the file when you made your changes and restart the SSH daemon. Security tip number 13. Login grace timeout. We will set login grace time to specify how long after a connection request the SSH server will wait before disconnecting. Edit the SSH configuration file. Scroll all the way down and search login grace time. Uncomment the line. By default, it is set to 2 minutes in the SSH config file, but we will change it to 60 seconds. Save the file when you made the changes and restart the SSH daemon. Security tip number 14. Configure SSH login level. By default, SSH logs everything depending upon the amount of information you want. You can change the value from info to verbose. Edit the SSH configuration file. Scroll all the way down and search log level and set it to verbose. Save the file and restart the SSH daemon. Now you can certainly monitor the real-time SSH logs. Security tip number 15. Restrict SSH logins to specific IP address. If you have more than one interface on your SSH server, or say you have multiple IP addresses on your server, and you want the SSH server to listen only on a specific interface or IP address, then you can do this by editing the configuration file. You can also configure the SSH server to listen to multiple IP addresses of the machine. Edit the configuration file. At the very beginning, you can see the desired setting. We can force the SSH server to listen only on a specific IP address of our machine. We can do this by editing the following line. Just enter the IP address to make the SSH server listen only on a specific IP address. Or if you want to add another IP address to this list, just add another line. Now you can certainly monitor the real-time SSH logs through the SSH command. To verify which interface is receiving and establish a connection, run ss command. Now you can see which interface is receiving the request and establish the connection. Security tip number 16. Hide the last login. You can also hide the last login user. Edit the SSH configuration file. Scroll all the way down and search print last log and set it to no. Save the file when you made your changes and restart the SSH daemon. Security tip number 17. Setting up maximum startup connections. We can configure SSH config file to set up a limit on connections to the SSH daemon. This is very useful to protect the SSH server from brute force attacks. We will allow here for this example only 2 concurrent connections. Open the SSH config file. Scroll through the file and search the max startups. Let's understand the colon separated values here. Random yearly drop can be enabled by specifying the 3 colon separated value: start, rate and full. After the number of unauthenticated connections reaches the value specified by start, SSH will begin to refuse new connections at a percentage specified by rate. The proportional rate of refused connections then increases linearly as the limit specified by full is approached until 100% is reached. At that point, all new attempts at connections are refused until the backlog goes down. Save the file when you made your changes and restart the SSH daemon. Security tip number 18. Do an SSH audit. This is not an internal SSH config file setting, but rather an external SSH auditor. Conduct an SSH audit for your system by going to sshdaudit.com. This free tool audits the configuration of an SSH server or client and highlights the areas needing improvement. Too many admins overlook SSH configurations when setting up new system. Unfortunately, the default for many operating systems are optimized for compatibility, not security. Security tip number 19 and the ultimate step. Of course, if you don't need SSH running on your computer at all, make sure it is disabled. Issue these commands to properly and permanently close SSH or any other services which you really don't want to run on your server. Systemctl stop sshd, systemctl disable sshd. Well, that's about it. Now it's time to wrap things up. In this video, I have addressed many dynamic configurations in which you may definitely learn hands-on about how to expertly secure your SSH protocol in a real scenario and production environment, whether hosting websites, domain, VPS or dedicated servers and so forth. Simply follow these steps and confidently manage remotely all of your business critical servers and install it as a persistent service. SSH now becomes a sophisticated and must-have implementation service that we use every single day to log into our remote Linux servers and take care of our admin duties. Without SSH, managing Linux servers would be more complicated and less secure. That does not mean SSH is configured right off the box to your liking, but you still need help with a specific situation. Comment below and I can help you out with it better. Hope this video helped you to know how to install, enable and secure OpenSSH on Linux easily. Alright, that's all for the now. I am hoping you have found this video informative. Thank you for being here. I will see you in my upcoming future tech video content. I look forward to join you through this lecture. If you want to see more awesome training content, make sure you click that subscribe button. Click it so you don't miss it. Thank you.